Okay, let's go. So, so far we've done two sections of the course, mechanics, and now we've just finished electricity. So now we're on to part number 3, which is waves. Got that? Wave motion. Continue? Okay. Oh yeah, sure, you know everything about waves from the active listening. Yes. Don't you? Yeah. So there are two types of waves. A transverse wave, which is also called an S wave, yes, and the other one is called a longitudinal wave. It's also called a P wave. I don't say S and P really. Transverse and longitudinal.
It's like same as earthquakes.
Yeah.
ST.
Yeah, I think this is more used in maybe geology or something. S waves and P waves. Yeah. Earthquakes are. Do you know which one?
SMP was
Yeah.
SCOM and then first PCOM
and then
SCOM, and finally LCOM.
Oh, I see.
Yeah.
Have you done? You did earth science, geography in school? Yeah.
I did also.
So you first S, then P, then
P and S.
P, then S, then L.
Yeah.
Is it okay?
Like L is like
the main.
I know my final thing.
Okay.
What is that?
We'll get to this now in a minute. I haven't explained what they are. Okay. So a transverse wave is a moving wave that is made up of oscillations happening perpendicular to the direction of energy transfer. Now I need to explain that with a picture, but that's the definition first. Yeah? So, transverse waves, what I mean here is the wave, it's like an ocean wave. You know, it's moving up and down across like this. So the key thing is, as the wave moves to the right, the motion, the oscillation is up and down. So the key here is that the vibration is perpendicular to the direction it's moving. Okay. Now, this is called the vibration is perpendicular to the propagation. This here is a verb, and basically it means movement. Well, sorry, it's not a verb there. Now here's a noun, and it means the direction it's moving. What would be the verb of propagation? Propagate. Yeah. And what would be the verb of vibration? Vibrate. So the vibration is perpendicular to the direction it's moving. Yeah? So, what are some examples here? Well, the example everybody knows is an ocean wave. So the ocean wave comes in, and as it's coming in, it's moving up and down as it's coming in. Yeah? Okay, so this is okay? You understand it? Yeah? Yeah, this vibration is this, and propagation is where it's moving. Propagation. So what I'm saying here is, as the wave moves this way, it's vibrating perpendicular to that direction. Yeah, like this, yeah. Yeah? Is the shaking. Yes. Propagation is the movement of the wave.
You can say motion of the wave.
The motion, yeah. Yes, and only used in waves. Yeah. Okay, back to the slides. So, the other one is longitudinal. So some people I think already know this one as well. Longitudinal wave, the particles do not move with the wave. The particle movement is parallel to the direction of the wave propagation. This means the particles move left and right, which in turn makes the other particles start to oscillate. This creates a wave. Very long definition. Again, I'll explain it in a minute with my hands. Some definitions are common in the exams and some definitions are not common. Sorry to tell you that these definitions are common in the exam. You can use a picture to help you explain, yes. Yes. But English is best. Yes.
Then we should use the all.
What I tell students is, this is me putting the definition in my words, and I'm perfectly happy if you want to restate it in your words. The key word here is parallel. So, for marks, they would need to see words like parallel, words like propagation, and words like vibration, or oscillations, oscillate. So what's happening here? Not yet, okay. Is another word for vibrate. Synonyms.
Common word?
Yes. Vibrate is more common, I think. Yep.
Oscillate is common in waves language.
Yeah. And not just waves, but waves, yeah.
Pendulum.
Pendulums too. Okay, so what does that mean? Let me draw it. Okay, so in this one here, you would have something like, here is a building, and then here is Superman. Well, you know what Superman looks like. An X. An S, yeah. So if you imagine that, he's sick. If he shakes the building here, the motion is horizontal. So what happens is when this part shakes left and right, then it makes this part shake left and right, and it makes this part shake left and right, and this continues along here until at the end, if Batman was standing here, so Batman, yeah. If Batman was standing here, he would feel this shaking left and right. So what's happening is, as the wave is moving through, the vibration is not perpendicular, the vibration is parallel to the propagation. So the vibration is parallel to the propagation. So the wave is moving in this direction instead. In the last one, the wave was moving up and down as it moves along, whereas this one, the wave is moving parallel as it moves along. Okay, so this is the longitudinal wave. So one example is like what you were saying, Andy, with earthquakes in the ground. The earth can vibrate like this from a center, vibrates outwards. Yeah. Any other examples of waves like this?
Ripples in the water maybe?
No, that's still transverse.
Oh,
But-
sound wave.
Sound wave, but ripples underwater. Underwater. So if you were, for example, if you were under, you're not really going to draw this, are you? All right, okay. If you were underwater and there was a small, like, explosion, the waves would move out, but these waves, they would be longitudinal. The water is vibrating outwards, and then interestingly, when it hits the top of the water, then it becomes a transverse wave. So this is an example where there's an explosion, there's a longitudinal wave vibrating up like this, hits the top, there's a big splash, and then the waves move outwards as a transverse wave.
In case of tsunami or something.
Yeah, like tsunami. Yeah, so originally in a tsunami, it starts off as longitudinal, and then when it hits the surface of the water, then it becomes a big transverse wave. Yeah? Okay, so we're clear on the difference between a transverse and a longitudinal wave. Yeah?
What is the red?
A bomb.
Oh.
Bat. Bomb. Yeah? Okay. Continue? You don't really have to draw these. These are just my pictures to help explain.
Yeah, help me to.
Okay, fine. That's good.
Maybe,
Good.
1 week later.
1 week later, okay, yes. Okay, continue? Yeah. Right, so we have our two waves, transverse and longitudinal. And there's a beautiful picture. This is a longitudinal wave, so you vibrate the spring like this and it moves across. And then transverse is with a rope, so you go flip it and then the wave moves up and down across. So I hope you should be completely clear about the two. Longitudinal and transverse. You understand? Yeah, okay, great. You don't need to draw this. So the waves have different parts of the waves have different names. So this lowest point here is called the trough. And the top is called the crest. The amplitude is half the distance between the crest and the trough. This is the amplitude. And the wavelength is the distance from crest to crest, or trough to trough, or middle, well, for wavelength is also the distance for one complete wave, up, down, up. So you need this vocabulary. Please draw this. Any more sweets?
No.
Oh. Can I what? Yes?
What's the actual?
Hmm? Oh, you want to go back to the last picture?
Here is
This is
horizontal.
parallel, and this is longitudinal. Yeah, and then the one where you maybe have a rope and you go like this, that's transverse. Yeah. transverse.
This one is transfer.
Yeah, transverse.
Transfer.
Yeah. Do you get the names, Patrick?
What is
Yeah.
O-U-G?
T-R-O-U-G-H. Yes, you say trough. Trough, like
Which part?
the lowest point. I know it sounds weird because trough sounds like it should have an F in it, and it doesn't because it's English.
And the curve?
Crest is the top. Yeah, highest point. Yeah? You got this? No, not everybody.
Total lunch slab.
Soup.
Only soup?
And bread.
Are you tired?
No, just lazy. So with soup I can just go soup, bread, finish lunch. And cheap. This is important also.
Yeah.
Okay, continue. You got this?
The soup, you can take soup?
No, I bring the soup from a supermarket.
Okay.
Yes. No, a canteen soup is okay.
But bread is healthy. Hard to eat.
The brown bread?
Yeah.
I like brown bread.
Last time I touched it and sounds like something.
Oh, they had old bread. Yes, not good. It was hard.
Yeah.
No good. No good.
And touch, it can't go in.
Solid. Yes.
Yeah.
Okay. Like stone. Oh my goodness. Okay, parts of way. Next now. So just a little bit of vocabulary. So please note displacement here is like the height. You know displacement from mechanics. So x is what we call displacement. Oh, okay, so before I go on, listen. You don't need to write all of this down, just the things you don't know. Okay, so displacement I think you already know. That's how far the particle is moved by the wave.
What is X?
Displacement. Remember this word? Amplitude. What's amplitude? It's half the distance from the top to the bottom. Or it's also the maximum displacement. Wavelength, lambda, the length of one wave from peak to peak, for example, or trough to trough. Period T, you know what this is. What do you think this is?
It's time for that
One oscillation.
Time for one oscillation. Time for one wavelength to pass. Phase difference, that is new. The time difference between the peaks of two different waves moving together. I'll explain that in a moment. Frequency F, what's this frequency? You know frequency? Remember frequency? What is it?
The number of
1 over
oscillations.
period.
Number of, 1 over time, or number of oscillations per second. Speed V, wow, how fast, you know this one.
No.
Now don't worry, I'll leave it there.
What is speed?
Yeah, I'll have to explain that one when everybody's ready. He's loud.
How many times?
Yeah, so frequency, like for example, frequency of 2 would mean you get 1, 2 waves in 1 second. Frequency of 3 would mean you get 1, 2, 3 waves in 1 second. Okay, so I need to explain phase difference. So phase difference is when you have 2 waves and they're moving together. So like, maybe I'll try and draw it. Sorry, do you need to write this more? I'm going to upload it as well. So phase difference, you have 2 waves moving together. So maybe this is 1 wave, and then this one here is another wave, and it's hard to see, but they're moving together, so it looks weird. It looks like it's hard to draw. But there's 2 waves moving together. The phase difference is the time taken between the 2 peaks to reach you. So if you're standing here and the first wave comes in and you start your watch, and then the second wave peak comes in after it, the phase difference is the time between the 2 peaks when you have 2 waves moving together. This is a little bit,
Different ways.
yeah, 2 different waves that come together to make 1 wave, and there's 2 different peaks moving, and the phase difference is the time between the 2 different peaks. This is very difficult, and we'll talk more about this in a later lesson. Yeah? Yeah?
Explain the word.
Phase difference,
No.
time,
No.
wavelength, peak,
Peak.
top, trough, bottom. Okay, continue? Yeah.
Peak and crest is
Oh, sorry, yeah, sorry. Peak and crest are synonyms. I said peak, didn't I? Peak is a synonym for peak is a synonym for crest. Yeah. Okay. So we have one equation, the wave equation, and it's a very simple equation. Remember, some equations we already have. So remember F equals 1 over T, and we can still use this, but we have one new formula for today, and that is the wave equation, which says the speed of the wave equals the frequency of the wave multiplied by the wavelength. V is speed, F is frequency, and lambda is wavelength. Yeah? Continue? You got this equation? Yep, okay. Some examples of each. So examples of transverse waves, light waves, waves from light, ocean waves, waves in a guitar string, you know, when you play a music instrument. Examples of longitudinal waves, that would be, I think, did I include earthquakes? Sound waves, underwater waves, or earthquakes. Waves in a spring, you have a spring going up and down. These are longitudinal waves. I think it's good because in the exam it's good to know some examples, because sometimes they would ask you for an example of each. Yep. Got this? Okay. So good news, there's just one question and then 3 questions for homework, and they're short. So can we write this down and I'll do it. Oh sorry, you need me to go back, Grace? Amanda?
You said no homework.
I never said that. You wanted me to have no homework. I never said no homework. Did I say no homework? I don't trust you. Okay, we'll do this question and then we'll finish. So write this down. Okay, will we have a look at this now? Uh-oh. Turned off. You got this, Grace? Was that breakfast?
No.
Snack? Okay. Come on. Right, let's have a look at this. So, you got a boy and he's sitting in a boat. And the boat is tied to a dock. So the boat isn't moving, it's just going up and down, bobbing up and down. So the boat is moving up and down because there is an ocean wave coming in. So he's moving up and down, and it says it's once every 2 seconds. So it takes him 2 seconds to move up and to move back down and back up again in the boat. And the boy looks out and he sees that the distance between the peaks is 4 meters. All right. Now, yes. Question is, how fast are these waves moving? So the formula, V equals lambda F. Do we know the lambda? The wavelength? We do. Do we know the F? We could, because we know that F equals 1 over T. So that's 1 over 2. What's the unit? Hertz. So V would equal 4 times 1 over 2. That will equal 2 meters per second. So this is how fast the waves are moving at. They're moving at 2 meters per second. So what that means is, if there was somebody on a surfboard on the peak of one of the waves, how fast are they moving?
2 meters.
They're moving at 2 meters per second. Okay. Ah, beautiful. So this lesson, there's only really one new formula. V equals lambda f. So it's not too difficult to start with. Now we still have 4 more lessons to do on waves before the semester's finished. And we have 4 hours tomorrow. I don't think we'll get everything finished. I think we might have to do a little bit after the break before the test. But the good news is, the good news is, in the exam you have 3 questions in section B. Question 1 is on, what do you think? Mechanics. Question 2 is on electricity, and question 3 is on wave. And because you only have to do 2 of them, I'm not too worried if I don't fully finish waves, because you can just do the mechanics and your favourite electricity question in section B.
But it will limit our choice.
Yeah, but nobody, like last time, nobody did the wave question in the exam.
They are easy, they are no
I tried
formulas.
to do, but I forget everything.
Exactly. So mechanics and electricity, I think.
Most of the wave question is definition.
Yes, which is why people don't like it.
Yes.
Yes, exactly. Okay, so let me just put the questions up for you. 3 short questions. No, really, honest.
Even if
Yeah.
I my graph.
Oh, yeah. No, what you mean to say is, did you find your graph? Because I don't think I ever got it.
How is that possible?
I don't know. It's your special ability. You know, some people have super strength. Some people have super speed.
And some papers have the ability to disappear.
Exactly. Yeah. We need to give you an X-Man name.
But does it matter?
Of course it doesn't matter. I mean, the next test matters. It's worth 10%. I care about this. Yeah. And in the next test you'll do your graph on graph paper. Yeah. Okay, did you get this? Yeah. What class have you got next? Or lunch? Lunch? Lunch class.
Steven, can we have our midterm test question papers back, like answer sheets, just to see like